Okay, we need to take a close look at the graphs of logs. We're going to look at the parent graph, and then we're going to look at one that has some translations, and we're going to look at some distinct information, domain range, asymptotes, and not specifically what the x and y intercepts are, but how many of them you have. So the first thing we want to do is let's take a look at this graph. Well, if you were to enter into your calculator the log of 0, then the calculator is going to give you an error message because the log of 0 is undefined. So that means that we have an asymptote, try to make this nice and dark, at x equals 0, and it is a vertical asymptote. And then if we put, for example, the log of 1 in, we do get a value of 0. So 1, 0 is a point. And we'll talk about some of the other points in a minute. And I can put in the log of 2, the log of 3, etc. And I keep getting some decimals. So for example, the log of 5 would give me 0.7. And if I get to the log of 10, I get a 1. So what's happening with this graph is that it grows up very, oh, I think I'm going to miss that one. I did. Very, very slowly, and it continues going up. Now, the question is, what happens between 0 and 1? Because the graph just doesn't automatically start at 1. So the question is, what's happening if I put in the log of 0.25 and the log of 0.5 and the log of 0.75? And you could put those into your calculator and look at the y values and plot them. And what you're going to find is that as you keep getting closer and closer to 0, the y values get more and more negative. So it produces this type of graph. So you don't just begin here, but you do have values here. And that produces a very interesting graph. So what we want to say for the domain is that the x values have to be greater than 0. So you want to look at this value, and that value has to be greater than 0. It can't be equal to 0 because that's where the graph is not defined. Now the range, think about the y values. Got lots of negative numbers for the y values, and then because I'm going to keep growing up very slowly, I'm going to have lots of positive numbers as well. So I'm going to get all reals for the range. And if you just throw this in your calculator, you really don't see this part. It kind of looks like it starts here, so you're going to answer some of these questions incorrectly. Asymptotes. You're going to have a vertical asymptote, but you're not going to have a horizontal asymptote because the horizontal asymptote, this graph keeps growing forever, so you can't have a horizontal because that would be like a boundary or an end behavior. Vertical asymptote comes from right here, set it equal to 0, solve if necessary. In this case, it wouldn't be necessary. So we just have x equals 0 for our vertical. Now, easiest way to identify the number of x and y intercepts is to look at your graph. X-intercept. I'm crossing the x-axis in one place, so I would have 1. Y-intercept. Look at where your asymptote is. It's on the y-axis. And you can't touch that vertical asymptote, so you're not going to be able to touch the y-axis, so you're not going to have a y-intercept. And that's the basic parent graph. Now let's look at what happens when it shifts a little bit. So we're kind of going to have, let's see, we're going to do the same information, but I don't want to talk about the domain and range until I get the graph up here. It will be similar. I do want to go ahead and talk about the asymptotes before I put my graph in. And then we'll talk about x-intercept and y-intercept after we get the graph. So if I look at this guy, I set it equal to 0 and solve, then I'm going to get a vertical asymptote at x equals 4, and a horizontal asymptote, not going to have one. So 1, 2, 3, 4, and here's our vertical. And then I'm just going to kind of ballpark. There's going to be some translating going on here, and if you wanted specific values, you could use your calculator to get some specific values. I'm just sketching a general shape of this graph to save some time. my domain. I know that I have to look at this guy, and what I can do is say x minus 4 has to be greater than 0, and I solve. X has to be greater than 4. The range, again, is going to be all reals. And then x-intercept, well, I am crossing the x-axis in one place, so I'm going to have one x-intercept. Y-intercept, because of this vertical asymptote, I'm not going to have any values in my graph that can touch the y-axis, so I'm not going to have one.